Hi and welcome to the fifth instalment of the circular functions revision. This is the first part of the short answer questions for the revision sheet that I handed out in my math methods class. You might find it a bit useful if you're not in my class. Firstly, we're converting from degrees to radians in terms of pi, so I need to make sure our answer has got a pi in it if it's needed. Always when we're converting, we need to multiply by pi over 180. That's the conversion from degrees to radians. And then we'll see if we can cancel anything down. I'm sure 3 is going to go into both of those things, definitely. 3 into 330 will be 110. That looks a bit like a 40, doesn't it? Anyone think I'd get used to this pen? 110 times by pi over, we were divided by 3, weren't we? 60. And then we can get 10 into both, so that'll give us 11 pi over 6. That's the first one. Second one that we'll do here, same conversion, so it's going to be 810 times by pi over 180. I'm going to cancel down by 10 here straight away. 9 will go into 81, and 9 will go into 18, so that'll give us 9 pi over 2. And the third one of these, 1080 by pi over 180. Again, I'll cancel down by 10s. 108, what's going to go into that? Well, now 6 goes into 108 and 18, so 6 goes into 108 18 times. 6 goes into 108 18 times, pi over 6 goes into 18 3 times, and then we can cancel down the 18 and the 3 for a 6. So the answer for this one will be 6 pi. Okay, let's move on to the next question. Convert to degree measure. So when we're converting 2 degrees, we need to multiply by 180 over pi. And straight away we can have our pi's will cancel down. 6 will go into 180 30 times. So we end up with 5 times 30 is equal to 150 degrees. Second one, same procedure, multiply by 180 over pi. Our pi's will cancel down, and 4 will go into 180 45 times, equals, so 7 times 45 will be 315 degrees. And same procedure for the next one, multiply by 180 over pi. Our pi's will cancel down, again 4 goes into 180 45 times. So here we have 11 times 45, which will be, that will be 415 degrees. Okay, let's move on to the next. Give the exact values for the following. So what I need to do with these, what I'm going to do with this is work out which quadrant it's going to be in. So I'm just going to draw myself a little unit circle, and I'm going to find out where 11 pi over 4 is. So if you remember, we've got pi over here 0, so I'm going to count quarters of pi until I get to 11. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 pi on 4 is going to be in the equivalent of the third quadrant. So 11 pi on 4 will be equal to sine of, that's going to be 3 pi. So we've got 1, 2, 3 pi, take away pi on 4. So it's actually pi on 4 back from the x-axis. And sine is positive in the second quadrant, so it's going to be equal to sine of pi on 4. Now we'll need to use our little triangles here. Pi on 4 is what we have as our 45-degree triangle. 1, 1 and root 2. So sine is opposite over hypotenuse, which will be equal to 1 over root 2, and you may be asked to rationalise the denominator, so multiply by root 2 over root 2, which will give us root 2 over 2 as our answer for that question. Now the second one that we have here, cos of negative 7 pi on 4. Again, what we're going to need to do is to work out which quadrant we're operating in. So I can use the same unit circle I've got up here, but we're going in a negative direction, so I'm going to head around that way, counting quarters of pi. So we've got 1, 2, 3, 4, 5, 6 and 7, so it's going to be in the equivalent of the first quadrant. So cos of negative 7 pi over 4, it's in the equivalent of the first quadrant, so that's essentially equal to cos of pi over 4. We can use our same triangle here. Cos is adjacent over hypotenuse, which again is 1 over root 2. And rationalising the denominator will give us root 2 over 2. Okay, now for the third one that we have, 11 pi over 6, and I might just clean up that unit circle at the top here. 11 pi over 6, I'm going to count in sixths of pi, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 pi on 6 is pi of 6 short of 2 pi, so that's equal to 2 pi, sine of 2 pi I should be saying here. Sine of 2 pi, take away pi on 6, as we said before, is pi on 6 short of getting around to 2 pi. It's in the equivalent of the it is in the fourth quadrant, so sine is negative there, so it'll be equal to the negative value of sine pi on 6. So what we need to do there is to get our second triangle, which looks like this. So that's a 60 degrees and 30 degrees, where that's 2, that's 1, and that's root 3. And sine is equal to opposite over hypotenuse, so it'll be equal to negative, pi on 6 is 30 degrees, so we've got opposite over hypotenuse, so it'll be equal to negative 1/2. Now if you have forgotten how to derive that second triangle, I'll just see if I can shrink this a little bit. For that second triangle, if I draw myself an equilateral triangle, so I've got 60 degree corners, and I call all of the side lengths 2. What I'm now going to do is to chop this in half, like so. And we're just going to focus on this left hand side here. So we've still got 2 there. This one's been chopped in half as 1. We have a right angle there, 30 degrees at the top, 60 degrees down here. And this side length, by using Pythagoras, we get 2 squared, take away 1 squared is 3, and then we take the square root of 3. So that's where this little green triangle that I first drew before came from. So when you can use that for any values of sine, cosine, tan for 30 and 60 degrees, 1, 2 and root 3. So you need to remember that one, and you also need to remember that one. Okay, that's it for this particular screencast, so see you next time.